Okay, welcome back. So, how many guys actually got a chance to play some of the activity, doing some of the simulation? Did any of you guys get to do that? Your mic needs some fixing. What's wrong with my mic? What are you talking about? Okay, that's fine. Good. See, you're just messing things up. No, they're fine. All right. So, yeah, how many guys got a chance to play some of the simulation activity? If not, that's going to be part of your homework to continue working on that. But hopefully some of you guys got a little bit. Good. Yeah, it's fun. So you guys can actually start playing around and going, actually physically move things and see, oh, I need two of those, and actually have two of them showing and going, oh, shoot, I only have one over here. I need one over here, and just seeing how it works. So it's really fun visual way of working with it. Okay, so balancing this. All we're doing is doing our coefficients. That's it. You don't have to do anything else. And what you have to do is just count how many of each thing you have on each side to balance. So when I look at this one, I can see that I have one Fe, one iron. On the other side, I have one iron. So that's matched. So I'm kind of happy about that. When I look at my bromine, I have a problem because in my reactant side, I have 2, but in my product side, I have 3. So that's not balanced. So when you have a 2 and a 3, a lot of times you try to find the common denominator, okay? So you want to try to make 6 because they don't match up until they get to 6. So what I want to do is I'm going to add 2 over here, so then that gives me 6 bromines. And then I add a 3 over here, and that gives me 6 bromines. So if we go back here and look at this, we have a 2 here and a 3 here. The only number that they have in common as we go through, the closest one common denominator is 6. So we want to get them to 6. So by adding a 2 here, that gives me 6 here, and adding a 3 here, that gives me 6. But then we get another problem. When I add 2 here, I now have 2 iron. I only had 1 iron to begin with, so then now I have 2 here. So then that's how you make this one balanced. Adding is multiplying. So it just depends how you do it. You can go 2, 2, 2, which is 6, which is 2 plus 2 plus 2. It's the same as 2 times 3. So adding and multiplying are the exact same thing. It's just done differently. So I'm not quite sure what you mean. So I could say I have 2 3s, 3 plus 3 is 6, or I can go 2 times 3. It's the exact same thing. You're doing the exact same thing, adding and multiplying, or the same. Just one, you just go 3 plus 3, or you go 2 times 3, right? Same thing, okay? All right, so how did we do with that one? How was our balancing? So here we have 2 iron atoms. Good, Cassie. We have 2 iron atoms over here now. We had to make a match. Then we put a 2 here, which means now we have 6 bromines. And we had to put a 3 here, which means now we have 6 bromines here too. Okay? Now, if you didn't get this, fantastic. You're learning, right? This is a learning thing. This is the part that I teach you stuff. You learn at the beginning stage, you do some practicing, and then at the end you'll have an idea of how to do this a little bit more competently than now. Now having this mastered is not an expectation, okay? So this one's a little different because this one is quite a bit bigger. So this might be one that you want to actually have a grid and looking at this. So remember PO4 is a polyatomic ion and it's set to treat it as itself. Don't look at it as a P and an O. Don't look at it like that. Look at it as a PO4. So we have that one there and we have a PO4 here. So look at it here. Okay. So when we look at this, I have 1 SN, 3 SN. I have NO2. I have 4 of them. And here I only have 1 NO2. I have 3 Ks. I have 1 K. And I have 1 PO4, and over here I have 4 PO4s. So this one is where you're going to just have to do trial and error. You guys are just going to have, there's no foolproof way of doing this. So you can start, they said, remember, do a hydrogen-oxygen atom, maybe start the polyatomic ones. So I have 4 PO4s here. Maybe I would think of putting a 4 over here and see what that would do. Well, that will give me 12 of these guys, because I'd have 3 and 3 and like 4 of those guys, so that would have 12 potassiums. So then what would I have to do here? So it's all going to change how you do things. Why does it change? Because it's reactants, because it's how everything gets put together differently. So you're going to take some of the products here, and then you're going to rearrange them, and they're going to turn into something different here. So they took some oxygens from over here, they took some of the oxygens here and put them over here, right? So it's just all a little bit different how everything combines. The outside of the brackets is telling you how many of those that you have. So for this one here, which is, I don't know what that is. I don't think it's sulfate. I can't remember what that one is. Whatever this one is, no, it's, I don't have my paper in front of me. Whatever this one is, there's 4 of them, okay? No, it's not like an exponent. It's just saying there's 4. It's not an exponent. Those are totally 2 different things. This is just telling you there's 4 of those compounds, okay? So that's like if I had 4 of these, I would have a bracket around it with 4 water bottles, and H2O would be, I'm just going to use that as an example, and there would be 4 of them. That's all that means. It's just telling you that there's 4 of those guys, okay? So this is how it works. So like I said, that would be the one I would look at because that's one of the more complicated ones. I have 4 of them over here. I have 1 of them over here because nothing's in brackets saying that's something different. It's just one PO4. That's one solid thing. So in order to get that to be a 4, I have to put a 4 in front here. As soon as I put a 4 in front there, I have 12 of these guys now. So then I have to look at the other side. How many do I have here? I have 1. So then I'm going to have to put a 12 in front of here, right? And that makes that match. But then when I put a 12 in front of there, my NO2 is 1. It now becomes 12. How many NO2s do I have here? I have 4. So then you just keep working through and you get this. So what this does, so there's my 4, there's my 12. We didn't have to do anything to this guy. So then when I had, so here I put the 12 here, that was the last thing I showed you. That means I have now 12 NO2. Remember, it's a polyatomic ion. Have your sheet in front of you always. Always have that sheet in front of you because if you're not going to memorize the polyatomic atoms, you need to know them and have something to refer to them. So when you look at this, you need to look at your polyatomic sheet before anything else and go, is that a polyatomic ion? Or is it meaning potassium, nitrogen, and oxygen? No, it's not. It means potassium and nitride or whatever this is, okay? So now I have 12 NO2s, because that's one identity. The 2 is referring to the O. That has nothing to do with the solid identity there. So if I have 12 of them, I have to look on this side. Here it tells me I have 4 of them, so I have to put a 3. That now means I have 12 of them. So I have 4 plus another 4 plus another 4, which gets me 12, okay, which is perfect. And then by putting the 3 in front here, that gives me 3 of these. Look over here. It tells me I have 3 of them, so they match. So let's look at this again. So I started with my PO4. I looked at my reactant because it had a 4. So that means I have PO4, 4 of them, PO4, 4 of them, PO4, 4 of them. So I have 4 of those guys, okay? 4, sorry, I said that wrong. PO4, 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 PO4. I have 4 of those things. So then I looked at the other side and I didn't have 4 of them. It says I only have 1, okay? There's only one polyatomic ion called PO4. So because I need 4 and there's only 1 of them, I put the coefficient 4 in front. So now they match. 4 PO4s on the reactant side and 4 on the product side. Okay, so that's good. Those match. But this messed up my potassium because now I have K3, so potassium, I have 3 here, plus another 3, plus another 3, plus another 3. So that's telling me I have 12 potassiums. So let's look at the product side. I only had, without that yellow there, I only had 1 potassium. So that's not good. Here I have 12. I need 12 on this side, so the only way I can get 12 potassiums on this side is to add a 12. So yay! So my PO4s are matching. I'm all happy about that. My potassiums are matching. So now I have to look at what else did I mess up by adding that 12. By adding that 12, I affected my nitride here, NO2. There's only one of them here, but that 12 tells me that one, there's now 12 of them. Okay, because remember, NO2 is polyatomic. It is treated as one entity. You can call it X if you want. So now I have 12 X's. How many X's do I have on the other side? Oh, look, it tells me I have 4 of those X's. If you want to change that in your head, go for it, whatever makes it easier. Instead of looking at this going, oh, it's an N, it's an O, there's a 2, there's a subscript. If that messes you up, maybe just treat it and call it as an X, call it something else if that helps you to work this out, okay? So now I have 12 of them on this side. I look at this side, only have 4. So it's telling me I have NO2, 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 NO2. So I only have 4, so I got to fix that. So if I have 4, I need to get to 12, I need to triple that, okay? So then I tripled it, those match, so 3 and 4. So I have 3 of these 4s, 3 of these, 3 of these, 3 of these in groups of 4, okay? And then I go, okay, what else did that screw up? Well, now it tells me I have 3 SNs on this side. Oh, yay, 3 SNs, I don't have to do any more matching, and then you're done, okay? So it's a trial and error thing. You just have to fiddle with it and go, okay, when I add this number, what else did it mess up? What did it change? Okay, do I have to balance that? Yay, that one's balanced. Okay, so now what's next? Oh, let's try this. Okay, did it screw anything up? Yes or no? Yay, it's balanced. So it's just a matter of going back and forth. So this one was a little bit tougher. It's a bigger one, and it had some polyatomic ions in it, but you're going to need to be able to do those. So it's good that you guys had a chance to practice this and for us to go over it together. Okay. No, you don't put a 1. Remember, we're lazy in math, so you never put a 1 anywhere. It's just like this. The PO4, guys, technically, there's a bracket around the PO4, and there's a 1 on the outside. We're lazy in math, we're lazy in science when it comes to math stuff too. You just don't put it there. But technically, there is a 1 in front of the SN3. Technically, there's a bracket around the polyatomic ion PO4, and a 1 is a subscript. Okay, so you just leave it blank. So you don't put anything here. That's exactly how it stays. Okay? All right. So work on this one. If you want to rewrite it out and see if you can figure it out, you can. You're going to have, what's really good is I'm giving you guys a couple worksheets with answer keys. That's really going to help you. Try to balance them on your own. See how it works. Check the answer. Look at the answer and go, how did they get 12 there? And then go back and look and go, why did they do 12? And try to work backwards. That will help you with your learning. That's a big thing, okay? And then if you get stuck, go, oh, I don't know, what do I do here? Go back and find one number that they changed and go, okay, let me work with that, right? So it's always good to have those answer keys before you do the stuff for me. Okay, and then this one is a busy one as well, because we have a few different things happening here. So we have CO2, H2O. None of these are polyatomic, okay? So none of these are on the polyatomic chart, so you treat them as separates. So we have 2 C's here, we have 1 C. Those don't match. We have 6 H's, we have 2 H's. Those don't match. We have 2 oxygens, we have 1, 2, 3 here. They don't match, okay? So when you do all the working, I'm going to put the answer up and we're just going to see how it actually works. So when you do this, let's do hydrogen, for example. I had 6 over here, and I had 2 over here, okay? So what I would try to do is find a way of getting to 6. So I would put a 3 here. That's probably what I've done to start. And if I put a 3 there, that matches the hydrogens, and let's look at the oxygens. Then I have 3 here, 4, 5, that didn't match, all that kind of stuff. So then you change your numbers. So it's all about trial and error. So let's look at the final answer. So final answer here, I have 2 in the front as a coefficient and 2 subscript, which means I have 4 carbons. Let's look at the other side. I originally had 1, so they put a 4 in front, which now gives me 4 carbons. Perfect. So let's go back here. So I originally had 6 hydrogens, but we had to put that 2 in front to try to balance my carbons. So when I did that, I have a 2 and the 6 hydrogens. So now I have 12 hydrogens because I have 6 hydrogens and then another 6 hydrogens. They doubled it, so now I have 12. Okay. So then I look over on this side, I need 12 hydrogens, so I have 2, so I need 6 2s, 2, 4, 6, 8, 10, 12. So I got 6 of those. Yay, those are matching. So now I gotta look at my oxygens. So I have 2, and here I have 2, but now I got 6 here, so I need a total, I got 8 here. I got the 4 and the 2 is 8, and then I have 6 here. So I got 14 oxygens on this side. Here I have 2, so all I have to put is a 7 in front, and now I got 14, okay? So it's just going to be, like I said, guys, trial and error, okay? Start with one element, start with carbon. Start with carbon and go, hey, I got 2 carbons here. Hey, I got 1, let's put a 2 in front, okay? And what's next? And then as you go along, you're gonna see, oh, I actually need more carbons on this side, or that messed this up and I have to change this. It's just going to be a matter of trying to figure it out that way. Okay, so hopefully, Luna, that gives you a little more, oh good, yeah, good, perfect. So it's just, like I said, guys, it's look at the hints, but you're just going to have to go in and just keep putting some numbers in and seeing if you can get them to start balancing and see if it screwed anything up. And then if it didn't, then make sure the rest are balanced and make sure those balance, and then double check it at the end. Okay? All right. So tips again. So you're only doing coefficients. You're not changing the subscripts. Balance the compounds first, those bigger ones first, and the polynomials. Do those, or one big chunk. Remember that. Have that sheet in front of you guys. Hydrogen, oxygen later. Trial and error. You just have to be patient, and then double check it when you're done. Okay? All right. So, Magical Merle, we are now at demo time. Yay! Okay. So, on your guys' worksheet, I've given you guys this worksheet. You are going to be filling in the grid, the table, as we are working along there. So I'm going to bring it up here for you. So you are going to be, we're going to have some temperatures that you're going to be testing, and then some observations you're going to be recording as it happens. So we're going to do some water and calcium chloride. You're going to tell me what the initial temperature is of the water, and then what happens after we put in the calcium chloride. You're going to tell me the change of temperature, and then we're going to talk about something called endo and exochemical, and that's what we're going to be working on at KSS on Thursday. So does anyone know, and think about exoskeleton and stuff like that. What do you think happens when it's an exothermic and an endothermic? What do you guys think that's referring to when we're talking about that stuff? What do you think that means? Does anyone have any guesses on that? Yeah, exo is out. Exo means out. So exoskeleton means the skeleton that's on the outside. Whenever you hear exo, that usually means on the outside. That means it's giving, and thermic is thermal energy, which is heat, that kind of stuff. So it means, exo means it's giving off heat, kind of losing heat. Endo, it's kind of, it's creating heat. It's making heat, okay? Sorry, this is not meant for you guys to be using to look at. You're supposed to print them off. Basically, what you're going to be doing is telling me what the initial temperature is at the start, what the final temperature is at the start, or final temperature is after we've done the actual little experiment, the change in temperature, exoskeleton, okay? So this is being recorded, so if you don't have this printed out or anything like that, you can add it in afterwards, okay? All right, good. So yeah, we're going to go now to the table. Do you need a minute or so? Nope? Okay, perfect. All right. Welcome. Okay, so we are at Miss Mac's Mad Scientist table. All right, so the first thing that I want you guys to do is we're going to record down, this is just water, and the first one we're going to do is calcium chloride. So the temperature is going to be on this thermometer. It's been sitting in here, and so we're hoping it's at room temperature now. And Magical Merle is zooming in, so we have some water. Let's see, which way do I have to spin this? Is that better? Something like that. So it looks like it's at, I'm going to let it sit there for a second. I'm just going to look at it. Let's put 21. So your initial temperature for the water before we do add in the calcium chloride is at 21. So what I'm going to do now is I'm going to add in the compound calcium chloride, and I'm going to put it into the water, like so. And there's going to be a chemical reaction that's going to happen, and I want you to record down what the temperature is after it's done all its changing. All right. So after it's done all its changing, there's going to be a temperature change. So right now, I don't know if you guys can see that, it actually has risen up to, right now, I'm at past 30. So it's actually gone up past 30. So we started at 21. And we've actually gone up a little higher. So has it given off heat or lost heat? What do you think? Has it given off heat or lost heat with this reaction? So let's put the final temperature. Yeah, it's given off. Good job, guys. Let's put the final temperature at 33. So let's put the final temperature at 33. And then you don't have to worry about doing that right now. But what you can do is afterwards tell me the change of temperature, and then tell me if that was exo or endothermic, and then write down some observations. So some observations, if we just looked at that, I'll go to the clear side, kind of became a solution. If you wanted to say, it's kind of made it cloudier water because the water was quite clear. The temperature increased, we went to 33. It's now starting to go down because the reaction is now over, so it will eventually settle itself down. So that would be some observations for that one. All right. Okay, so I'm going to take that out because I'm going to need that thermometer here. We only have 2 long ones, so Joseph not actually having a major lab with you, so okay. So I'm going to put that one in there. Oh, I've lost some of my vinegar. Okay, so we're going to do the next one. And if you look at the thermometer on that one, I don't know if you can see that quite clearly. So now we're going to do water and some baking soda. So if I twist that, we're roughly around 21 again. So your starting temperature for the water and baking soda is going to be 21 again. Now I said baking soda because baking soda and sodium bicarbonate are basically the same thing. Sodium bicarbonate is more of a concentrated version of what you find in baking soda. Okay, so it has sodium bicarbonate in it. When I wrote this experiment up, I actually never got my supply of chemicals yet. It just came in on Friday for me, so I was like, yes! So we're going to use some actual sodium bicarbonate, and we're going to put it into the water and see what happens to the temperature there, okay? So definitely when cloudy, mix that up a bit and see what happens to the temperature as it goes. So sometimes it's just going to take a little bit. We'll just let that one go. Okay, so let's have a look and see what we got here. So it went down to, I would say, 18. So did it absorb heat or did it give off heat? What did that actually do? What do you guys think? Did it give off heat or did it absorb heat? Perfect, it absorbed heat. So that would be an endothermic. So endothermic is when it takes in some heat versus give off heat. Excellent. So this one, if you look at them now, you can see they're actually quite clear now. So that one that I did this, and what's happened with the baking soda in this one? When I put the baking soda in the water, it's cloudy, and then what happened? It went settled to the bottom. Does anyone remember what that was called? We went over that in the first class when we were talking about, not the first class, but when we were talking about chemical reactions and looking at them, and we looked at the chemical chart. Do you guys remember that? What is that called when it's like muddy water? When we mix it up, it's all muddy and stuff, and then after we let it sit, it goes down again. Does anyone remember what that was called? Does anyone remember what that guy was called? I'm going to have to clean that off too. Starts with an S. No, not density. Nice try. Density kind of explains how things float and that sort of thing. It starts with an S. Sus. Does anyone remember? Close. Suspension. So it was called a suspension. So orange juice is a suspension, muddy water, tomato juice, all those are suspensions. So that's what this is going to be, because right now the sodium bicarbonate is now at the bottom. Okay, and if I mix it up, it'll be in there, and then it would go off of that. All right, so now we're on the third one. I have got water and vinegar all over my papers here. So the next one we're going to do is vinegar and the sodium bicarbonate. So I have the vinegar in here, and the vinegar is not at 21 at room temperature. We're sitting at about 19. So I'll show that to you guys. So it's sitting at 19, so that's going to be the starting temperature for that. Okay, and what we're going to do is add sodium bicarbonate. Does anyone have any predictions of what happens when we have sodium bicarbonate going into vinegar? Think about sodium bicarbonate as originally baking soda. What happens when those two go together? Explosion! Fizzy, buzzy, yeah, that's excellent. Okay, so make some observations as we do this. All right, there we go. We got fizzing and buzzing, bubbling going on. Woohoo! Look at all that. Perfect. And the temperature, hard to see, but it has gone down. It has gone down. So it is now approaching roughly, I think, about 15. Oh, I think we're closer to 14 now. I'm just going to keep my eye on that guy. We might make 14 our final one on that one. Okay, let's just double check, see if it's gone any further. Yeah, let's make that one 14. So that was, heat was absorbed or given off? What do you think, guys? Heat absorbed or given off? Which was that one? What do we think? Absorbed, good. So we have an endothermic reaction. So we went from, what was that at? 19 to 14. Okay, so we lost some there. Yeah, and it's staying quite steadily at that. So I'm just going to keep that guy in there for now. Clean this little guy off. Okay, and the last one is, this is a combination of water and the sodium bicarbonate, and again, it's a suspension. So when I put it in here, I just mix it around a little bit to keep it together, more like a solution. And I have about 22 on this guy. I used a little bit of hotter water when I started because I wanted to dissolve a little bit of the baking soda as best as I could. So we're going to start with 22 on this one, and I'm going to add in, I can close this guy now. I'm going to add in the calcium chloride, and I'm going to put it in to this, but I'm not going to use this actual one. I'm going to put it into here. So I'm going to put the thermometer back in there, mix it up again, and I'm going to pour some into this, okay? And now I can stir that guy up a little bit. Hopefully I got enough material, enough of the baking soda in there. And get ready to record down the observations of this. Okay, so what do you see happening there? Oh, we got some bubbling going on. Oh, that one's even better than the vinegar and baking soda. Woohoo! There, that sucker go. And then you can probably see the thermometer has gone up from where it was. So still bubbling. This one has a very, very major reaction with the baking soda, the water, and the calcium chloride. They both react quite well and have an amazing bubbling effect. All right, so let's see where we're at so far. Okay, so far, oh, this one didn't go up too high. We're at about 26-ish. Awesome. Yeah, we started at 22. We're about 20. We were at about 26. We've gone down a little bit. So the temperature has gone down. So if you guys want to put the final one at 26, that will work just fine. Okay. And then, so yeah, so what we've just done here is looked at some chemical reactions, and I'm going to show you guys next on the slides the chemical formulas, what the reactants started with, what the products did, because now we have some rearranging, right? We have some stuff that was created, obviously, because it's the chemical reactions were happening. Once you lose or get heat, there is a chemical reaction. Once there's bubbling, there's a chemical reaction. So when that happens, we know that we have the same elements, but they've rearranged themselves. And if I would have done a closed system and weighed these like your home lab, we would see that it would have been the same masses on both sides of the equal sign, okay? So on your sheet of paper, you have the initial temperatures. So just going down the line, your initial temperatures, 21, 21, 19, and 22 is kind of what you guys got. And then we have the final temperatures. We have 33, 18, 14, and 26. Then you show me in the next column the change of temperature. Tell me if it's exo or endothermic on the next one. And then you have some observations on the other side. Now, if you notice on the sheet, there are actually 4 questions I want you to answer. You're going to have to answer that, not now, but you'll have to answer those questions, okay? So there's science. Okay, so we're going to go back to the slideshow. Get back to that. Yeah, so that's so cool. Okay, let's go to this slide because it's fun. Because my minions are dancing. I like this one because they dance. Little dancing machines. Why do I have a black screen? Oh, because I have to click it on. That's why. Never mind. There we go. They're so excited. I know, so it's fun. So it's kind of neat to see that you can get a bit more things you add into chemicals with water. You can get some really great things. Yeah, it was suspension. Yeah, thanks, guys. Okay, so on your sheet of paper, at the bottom, I have something that says demo time. So we're on the 3rd page, bottom, demo time. So we had the reactants. So I'm going to get you guys to write this down. And this is where we did the baking soda and vinegar. We're just going to look at those ones right now. So I want you to write down, this is the reactant. So this comes before the arrow. So before the arrow, we had our sodium bicarbonate, which is C2H4O2. We added in vinegar, which is NaHCO3. Actually, those are reversed. Sorry, those are reversed. But yeah, same idea. Those are the reactants that are in there. So write those down. And if you want, put the heading baking soda and vinegar, so you know that's the one that we did. And then when we did the reaction, when we performed the experiment, we had a chemical reaction. And what that does is change what happens with the reactants and how they are all arranged as the products, okay? So when we put them together, we end up getting these as the products. So have an arrow going from the reactants, and now these are the products. So you have now things have been rearranged. So we have CO2, H2O, and then we have NaC2H3O2. Lots of numbers, lots of subscripts. Believe it or not, this is balanced. So what's really cool about this reaction with baking soda and vinegar is that it's balanced already. So if you look at it, the number of C's in the reactants and the products are the same, H's are the same, O's the same, sodium's the same. So you don't actually, the skeleton equation becomes the balanced one. So that one's really cool. Yes, yeah. So that's that part, okay? So what I'm going to get you to do now is we're going to look at the other one. We're going to look at the one where we had the baking soda with the calcium chloride, okay? So here is the reactants, okay? So I'm going to get you guys to write this one down. So this is the baking soda and the calcium chloride. So the reactants we have, and I've given you a hint, there's a 2 in front with the sodium HCO3, okay? And one of those is a polyatomic ion. Okay, and then we have CaCl2. So that's the reactant. So then you're going to draw an arrow from there. And then what we're going to have is I'm going to show you the products. Write the products down. And I'm going to give you guys 1 minute to write the products down and try to balance it. It's a really easy balancing one. I just want to get you to understand. Sometimes they don't always balance. Like the first one we did balance, this one doesn't balance. So here are the reactants. Have those written down. And here are the products. So what I want you to do is I want you to balance these out. So I'm going to show that. Okay, so I'll give you guys 1 minute to write all that down and then come up with the balanced equation. Okay. Okay, so with this one, all you had to do was add a 2 in front. So I just wrote down the products here. So all you have to do is add a 2 in front of this one to make it balance, to make sure you have enough here. So if you look here, I have a 2 sodium. Here I didn't have a 2 sodium. So I add the 2 there, and that allows my CLs to balance as well, because I have 2 there, and that allows me to have 2. Okay, so yeah, so that is an example of conservation of mass. They would both have the same, showing the rearrangement of the atoms, and that nothing, even though there was a chemical reaction, the atoms stayed the same. And then talking about the different types of reactions, endothermic and exothermic. We're going to be looking at that when we actually go to KSS, which is going to be cool. So reminder, KSS will be on Thursday. So this Thursday, no class Wednesday. That's okay, nothing was in the way. It was just that 1-2 that you had to worry about. So KSS, you need to be there at 8:45 and get picked up or be able to get home at 10:45. Bring a pencil and just make sure, try not to have things in the way, loose clothing, or be able to like put your sleeves up or something like that, just in case. We need to worry about that. So make sure that's arranged. Okay, so field trip form, guys, you need to have those into me. So there is a drop-in spot for you guys to hand in the field trip forms. There's a couple spots to open them up and 1 spot to hand them in. Please hand those in. I think I only have 1. So please get a signature on that, because you guys need to have that handed in to me for Thursday. If it's late, then you can get it signed when we're there. But please try to hand it in on time. That'd be fine. Okay? Okay. So if you're unable to attend, it would be super if you guys were able to attend. If you are not, please just let me know what's going on and just send a Moodle message for me, please. So homework, I've given you 2 practice worksheets. So if you're struggling a little bit with the balancing, do some practicing of it, see how it goes, because they do have the answer keys. Have a little bit of fun with the simulation. Maybe play that first a little bit. And then once you've done that, then that will help you with the one that you have to hand in. And then there are some lab questions that were at the bottom of that page from what we just did, that demo, okay? Okay, good. You'll be a little bit late, Em. Okay, so just try to be there, because we're going to be in a classroom, and I need to make, you don't want to get lost, so try to be there on time, okay? All right, so field trip forms in to me, get those in, get those signed, hand in to me, please. The demo that we just did, there's about 4 questions at the bottom of the page. And you have 1 hand in to do, and have some fun with that simulation. Yes, it will be live as well. Yeah, so if you're unable to make it, I expect you to be live, or I expect you to be there in person, okay? Yes, yeah, I expect you to, well, I don't know, you have some traveling time. I don't remember what the room number is. I don't know what the room number is. That's why we're going to kind of all meet together at 8:45 and all travel as a group. So try to be there, communicate with me as much as possible about what you're going to do. I think it's room 147. If not everyone's there, you can go to the office and they'll direct you to where we're supposed to be going. But I think it's room 47. Boy, I can't remember. All right, maybe tell your dad it's at like 8:30, and then maybe that will work. Sometimes that works, all of this. Yep, everything's on the website. It's all on the Moodle site. Remember, no class on Wednesday, but if you need to come in to use the balance or anything like that, you're welcome to do that. Just arrange that with me. Dragoons, you got to sign up. It's on the maid page. Get some basil if you want some basil. And yeah. Do we hand in any of the sheets? No, you don't hand in your notes, guys. So last time, I've mentioned that last couple times, you don't hand in your notes. That is for you. You hand in the stuff that I tell you need to hand in. So in this case, you hand in the one assignment that's on the page, and then the lab questions are at the bottom, okay? Yeah, you have socials tomorrow. Nope, no science tomorrow. Okay, yeah, so that is good. So everyone, any other questions? So no science on Wednesday. Science is now going to be on Thursday, and you only have socials tomorrow, okay? Okay, so awesome, guys. Hope you enjoy the class, and I'll put that in KDT, yeah. And I will see you guys. I'll see you guys on Thursday. Okay, see ya.